we go back to linear regression. When you're trying to find the strength of relationship, you use correlation. But with simple linear regression, you can do more because you can try to predict the value of y based on the value of x. So here's an example. You have the risk factor which is H, and the outcome of interest is cholesterol. So basically you are trying to find relationship between H and cholesterol. So if you're trying to find relationship, you can either use correlation or regression analysis. Both, since why? Because cholesterol level is continuous data, H also are also continuous data. So you can use simple linear regression. So in this part of the lecture, we're going to talk about regression. We already finished with correlation earlier. Okay, which one is the risk factor here? The risk factor here is H. The outcome is cholesterol. Okay, so here's an example. So you can see here, you can see the line there. There's a linear relationship. This is how you do it. So when you run the analysis, you're going to get what we call the scatter diagram. This scatter diagram indicates if you increase the age by 1 year, how much the cholesterol level will increase. So you can see here, if you increase the age by 1 year older, you increase the age by 1 year older, you will increase the cholesterol level by 0.06 millimole per liter. Okay. If you increase by 10 years, then you increase the cholesterol level by 0.6 millimole per liter. So that's the example. Okay. So how do they decide the line? The line is decided by using the concept of least square differences, LSD. So the line that end up with the least square differences between the line and the observed data, you will get the best line. Okay. So these are all explanation how they end up with the line. Okay. So here's explanation about how they end up with the line. Okay. So this one line here like that. Based on the observed data, these are all the observed data. So is this a good line or not? Let's compare the other line. These are all the differences. Okay. So differences between the observed data and the sum of the squared differences. So you can see there 2 minus 1, 4 minus 2, 1.5 minus 3, 3.2 minus 4. The sum of all the differences is 6.89. So we come up with another line, okay, which is horizontal in nature. Okay. So you get the differences. The value of the differences is 3.99. So in fact, instead of having the line sloping like that earlier, the horizontal line is a much better line because it comes out with least square differences. Okay. So that is how they end up with this formula of how to calculate the best y equals a plus bx to get the least square differences. Okay. The outcome is never determined by one risk factor. It determines by many risk factors. So you have this example here. So in this example, we have the cholesterol level. Your cholesterol level is not only determined by your age. It is also determined by your diet. Those who went downstairs just now to eat chicken with tomato sauce. You got chicken with masak lemak, ikan masak pedas, ikan masak asam. So what you eat determines your cholesterol level. Whether you exercise or not. Okay, you guys may be young, but you spend your weekend coming to classes, so you don't exercise. Socioeconomic status, you spend more. You guys are mostly professionals. We are of the higher economic status, so you got more money to spend on good food. But the food, when you say good food, it may not be necessarily good for your health, but it may also contribute towards higher cholesterol level. Okay, so the concept of multiple linear regression is most of the outcome are determined not by one factor only, but by many other factors. So when you have this scenario, you have this option of trying to determine, trying to explore, trying to find how much each one of these factors contributes towards the final outcome. And the formula for multiple linear regression is like this. So you can see it's very long list of formula. But this one all comes from the basic formula. The basic formula is y equals a plus bx. So here your y equals to a becomes beta 0 plus beta 1 x1 plus beta 2 x2, so on and so forth. Okay. So all this, if you have 4 risk factors, then you have 4 risk factors inside the formula. Okay. Usually we do this with continuous data, but you will see situation where they use categorical data to run this analysis. If they do it so like that, we don't really call it multiple linear regression, we call it general linear regression. Why? Because they are following the general linear model method of analysis. So I'm not going to worry about that. At the end of the day, once you run all this analysis, what do you want? You want to have this table to put inside your thesis. So this is a table of simple linear regression for all the risk factors. Okay, so that is the aim of the exercise. Okay, what is more important is for you all to learn how to calculate. So again, I'm going to repeat what I said earlier. For correlation and for linear regression, we have what we call the scatter diagram. Okay, this is x, this is y. X is always the risk factor, y is always the outcome. Which one comes first? X comes first, then followed by y. Okay, risk factor comes first, then you have the outcome. Okay, so when you have the y equals a plus bx, this is a, this is a. If this line starts at 0, where the line crosses the y-axis is the value a. B is the steepness of the slope. What does it mean? When b equals to 0, no relationship. Okay, so you don't want b to be equal to 0. What do I mean by b equals to 0? If b equals to 0, the line will be like this. Straight line. Okay, so we don't want b to be equal to 0. If b equals 0, means there's no relationship between x and y. So the b, if it is positive, the line will be going up. The b, if it is negative, it will be going down. This one b here, b stands for regression coefficient. Just now, r was correlation coefficient. R square coefficient of determination. Okay, b here is regression coefficient. Okay, so because b dictates the shape of the slope. Okay, kecerunan, the steepness of the slope. As stated earlier, if you know the value of a, you can already determine the value of b. But in our exercise, we always determine the value of regression coefficient first. The value of b is very, very difficult to calculate. Why? It is so complicated. But if you look carefully, it is part of the formula that you use for correlation. Okay, if you remember back your correlation, this is a, this is really b. Okay, remember we did correlations now? This is a and this is b. So if we already calculated the ABC for correlation, you can get the regression coefficient directly just by removing the square root and by removing the c. Immediately you get the answer. This one is slightly different data set. The relationship between cholesterol level and systolic blood pressure based on the data given. You just combine everything together and you get the value. You just get the sum of x, the sum of y, the x squared, the y squared, the xy. You put it inside here, change the value inside here with this data, and you get the value of the regression coefficient. Once you got the answer, you get the b, the regression coefficient. You need to get the a. To get the a, you are going to reverse back the formula y equals a plus bx. You're going to revert it, become a equals y minus bx. Then you put in the y and you put in the x. Where the x and y come from? They are the mean of the x and the mean of the y. Ni x, ni y kan? 6426 divided by 32, you get the mean of x. 4631 divided by 32, you get the mean of y. And then, once you got the value of the constant A and the regression coefficient B, you put into this formula, systolic blood pressure is determined by constant minus the cholesterol level. Here are the following testing for significance. This one, no need for you all to do. I'm just trying to show you that there is a formula for them to calculate the residuals based on the y observed and the y that is calculated by the formula.